Hello, this is a recording of Unit 5, Lesson 2, Patterns of Circulation in the Atmosphere. Winds. The surfer in Figure 1 is moving over the top of a fluid, water. But the surfer is also moving through another fluid called air. Air, like water, flows from place to place and does not have a fixed shape. But what causes air to flow? Causes of winds. Air, like most things, moves away from high-pressure areas to low-pressure areas. When there is a difference in air pressure, air moves and wind is created. Wind is the movement of air parallel to Earth's surface. Higher and lower pressure areas are results of the unequal heating of the atmosphere. Air over the heated surface expands, becomes less dense, and rises. As the warm air rises, its air pressure decreases. Meanwhile, if another area is not heated as much, then the air in that area is cooler and denser. The denser air sinks and air pressure increases. The cool, dense air with a higher pressure flows underneath the warm, less dense air. The difference in pressure forces the warm air to rise. Measuring wind. Wind is a valuable resource, and understanding wind can put this resource to work for us. To identify winds, they are named using the direction from which they originate and their speed. A wind vane is helpful in seeing which way the wind is blowing. The arrow in the wind vane points in the direction from which the wind is blowing. Winds can blow from any of the four directions, north, south, east, and west, and they are named by the direction from which they are blowing. For example, a north wind blows from the north to the south. Wind speed and pressure can be measured with an anemometer like the one in Figure 2. An anemometer has 3 or 4 cups mounted on the ends of horizontal spokes that spin on an axle. The force of the wind against the cups turns the axle. The anemometer tracks the number of rotations, and that number is used to calculate wind speed. Local winds and global winds. Because of Earth's shape, surfaces, and tilt, the sun cannot evenly warm all of Earth at the same time. Different parts of Earth are warmed at different times and rates. This unequal heating and Earth's rotation affect wind and weather conditions on land, both in local areas and over global regions. Scientists use this understanding to make a model, such as a diagram or a map, to describe and predict wind patterns and their effects. Local winds. Have you ever noticed a breeze at the beach on a hot summer day? Even if there is no wind inland, there may be a cool breeze blowing in from the water. Winds that blow over short distances and affect local weather are called local winds. The unequal heating of Earth's surface within a local area causes local winds. These winds form only when the global winds in one area are weak. 2 types of local winds are sea breezes and land breezes, which are illustrated in Figure 3 below. When sunlight reaches the surface of Earth, land warms up faster than water. The air over the land gets warmer than the air over the water. As you know, warm air is less dense, and it rises, creating a low-pressure area. Cool air blows inland from over the water and moves underneath the warm air, causing a sea breeze. A sea breeze, or a lake breeze, is a local wind that blows from an ocean or a lake. At night, the land cools faster than water. The air above the land begins to cool and move under the warm air rising off of the water. The flow of air from land to a body of water forms a land breeze. Global winds. The patterns of winds moving around the globe are called global winds. Like local winds, global winds are created by the unequal heating of Earth's surface. However, unlike local winds, global winds occur over a large area. Figure 4 shows how the sun's radiation strikes Earth. Direct rays from the sun heat Earth's surface intensely near the equator at midday. Near the poles, the sun's rays strike Earth's surface less directly. The sun's energy is spread out over a larger area, so it heats the surface less. As a result, the temperatures near the poles are much lower than they are near the equator. Global winds form from temperature differences between the equator and the poles. These differences produce giant convection currents in the atmosphere. Warm air rises at the equator and cold air sinks at the poles. Therefore, air pressure tends to be lower near the equator and greater near the poles. This difference in pressure causes winds at Earth's surface to blow from the poles towards the equator. Away from Earth's surface, the opposite is true. Higher in the atmosphere, air flows away from the equator towards the poles. Those air movements produce global winds. The Coriolis effect. If Earth did not rotate on its axis, global winds would blow in straight lines. Instead, global winds get deflected or shifted by Earth's radiation. As the winds blow, Earth rotates from west to east underneath them, making it seem as if the winds curve. The way Earth's rotation makes winds curve is called the Coriolis effect, as shown in Figure 5. Because of the Coriolis effect, global winds in the northern hemisphere gradually turn toward the right. A wind blowing toward the south gradually turns toward the southwest. In the southern hemisphere, winds curve towards the left. Global wind patterns. The Coriolis effect, global convection currents, and other factors combine to produce a pattern of calm areas and global wind belts around Earth, as shown in Figure 6. The calm areas where air rises or sinks includes the doldrums and the horse latitudes. The major global wind belts are the trade winds, the polar easterlies, and the prevailing westerlies. These wind belts are not stationary and can shift about from month to month. Effects of global wind belts. Global winds affect local weather by moving masses of air from one place to another. The air masses affect the temperature, rainfall, and air pressure. Overall, the global wind belts move energy away from the equator and toward the poles. This helps to equalize the temperature, allowing life to survive in a larger range of latitudes on Earth. Jet streams. About 10 kilometers above Earth's surface are bands of high winds called jet streams. They generally blow from west to east at speeds of 200 to 400 kilometers per hour. As jet streams travel around the Earth, they wander north and south along wavy paths that vary over time. The jet streams greatly affect local weather. As shown in Figure 7, the jet streams traveling over North America bring a variety of weather conditions. Weather forecasters track the jet streams to predict temperature and precipitation. If the polar jet stream wanders farther south than usual in winter, it could mean colder temperatures and snowy conditions for areas north of the jet stream. If the jet stream wanders farther north than usual, then warmer air moves up from the south and warmer temperatures are predicted for areas south of the jet stream. Okay, that concludes Unit 5, Lesson 2, Reading, Patterns of Circulation in the Atmosphere. Thank you for listening.